Hello everyone, welcome to my tutorial. So let's talk about the basic concepts of HDFS. By the word HDFS, we means Hadoop Distributed File System, okay? And remember that this is made of Java. So by the word HDFS, we can tell that this is a Java-based distributed file system that holds a large amount of data. And the first thing that we need to consider is the distributed storage. Okay, so by the word distributed storage, we means that let's say we have a name node 1, okay, and this is going to be connected with C1, C2, C3, C4, and C5. Okay, so all of these are we are calling the nodes, and by the word nodes we mean that these are nothing but the general computers that we are going to use day by day. And instead of storing data, so let's say we have a 10 terabyte of data, okay, 10 terabytes of data. So in a normal situation, we could consider that we are going to have a single machine with 10 terabyte of data. But in the case of Hadoop system, we are going to have each with 2 terabyte. Okay, so this one is going to have 2 terabyte, this one 2 TB, and this one 2 terabyte. This one is 2 terabyte. And this is how we are storing data across the network. So this is going to be considered as a cluster, right? So this is a cluster and this is a distributed storage. This is a distributed system because we are going to have so many computers connected with each other. And at the same time, what we're doing is we are dividing the storage among all the computers within the network. So this is why we are calling that to be the distributed storage. So the next thing we are going to talk about is the distributed and parallel name node. Okay, and then we are going to have C1, C2, C3, C4, and C5. So let's say that we, in absence of these system, we're going to have a single computer or a single machine, and then we are going to have 10 terabyte of data, and the processing of 10 terabyte takes, let's say, 60 minutes. Okay. Now, in the case of name node and the data nodes, so these are nodes, okay? In the case of Hadoop system, the parallel computation, what we're doing is we are dividing this 10 terabyte of data among these 5 machines. So the processing is done at the same time. And when all of these 5 machines are processing, they are taking how much time? They are taking 60 by 5 equals 12 minutes. So this is the beauty of the parallel computation in Hadoop, that it is faster because why? It's faster because we are dividing the task among the nodes. Now let's talk about the horizontal scalability. So there are two types of scalability. One is called the vertical scalability, and the other one is the horizontal scalability. Okay, the basic difference is that, so let's say we have a computer over here, and we are adding some more processing to it. It becomes like this, and then we are adding some more processing to this, then it becomes like this. Okay, this is called the vertical integration, okay, or the vertical scalability. But on the other hand, the horizontal scalability is like this. So we are going to have, rather than the same computer putting more processors, so what we did over here, let me write. processor becomes this, and then I'm adding more processor to become this. But in the horizontal scalability, what is happening? I'm just adding more computers with the same size and same processing. So I'm saying that this is going to have same processing. So rather than increasing the processor in the one single machine, in the horizontal scalability, this is the horizontal scalability, what I'm doing is I'm just adding more processing. I'm just adding more computers to this. So the benefit of this is that if we are going to add individual processor within the machine, it is more costly. But over here, it is less costly, okay? So whenever needed, I can just add more machines to my network, okay, to make it more horizontal scalability. The other good thing about is that let's say that I'm processing 10 TB over here, and this machine is gone. It's not in the network. So what happens is it is going to have a single point of failure, okay? Because once this is down, I'm not able to process anything. But on the other hand, let's say we are going to have over here 2 terabyte, and then this is gone, okay? So this is down, but still I can process on the network with the other machines, okay? So I still have 8 terabyte of data that I can process with the horizontal scalability. So Hadoop actually gives us this good benefit that we can do the horizontal scalability and avoid the single point of failure. There are some other benefits of HDFS. One is the cost that I had said, that in general deployed to a commodity hardware. Okay, so commodity hardware means like we can just add up with new computers with just the simple configuration, and still it will work. It is more fault tolerant because, as you can see, with the horizontal scalability, even one node is down, the network is up and running, and it's more fault tolerance. Then it is high throughput, and throughput is the amount of work done in a unit time, and it talks about how fast we can access the data from the file system. Okay, so you can see that it gives you an insight about the system performance. Okay, and you can see that with a single computer, if it takes 10 minutes, 60 minutes to process 10 terabytes of data, whenever we are going to have more machines, it is going to be divided. So this is the high throughput. So these are the benefits of HDFS system, and we'll look into the architecture of it in the next tutorial. Thank you.